Sometimes, instead of wanting to know the future value of investment, we know where we want to be in the future, and what we need to figure out is how much to start with. Here's an example. Suppose you want to accumulate $80,000 for your child's college fund in the next 18 years. How much would you have to start with in order to have that $80,000 after 18 years if you invest the initial amount in an account that earns 6.8% annual interest that is compounded quarterly? Now, our original equation or formula for compound interest was A equals P times 1 plus R over N to the NT. That formula solves for future value. But what we want to do in this example is we want to find how much we start with, which is actually P. What we're trying to do here is we're trying to find P. So another way that we can write this formula is to have it rearranged for P. And a little reminder, in mathematics and algebra, if we want to isolate something that is multiplied by something else in an equation, we can divide both sides of the equation by that thing we're trying to get rid of. So if we divide both sides by that stuff in the parenthesis and that's raised to the exponent, we'll be able to get P by itself. So this formula can be rearranged so that P is equal to A, the future value, divided by 1 plus R over N to the NT. So this is an alternative way of writing the compound interest formula that allows you to find a starting value. So it's just an alternative way of writing the same formula. It just kind of rearranges it a bit. So now for our particular example, we could go ahead and use that formula to figure out how much we have to start with to make sure we get $80,000 after 18 years. So we're solving for P or calculating P. We're going to have in our numerator the amount we want to end up with, that $80,000. And our denominator, we're going to have this stuff in the parentheses and then that has an exponent. Remember, we're always going to start this with 1 plus. Now we'll have the interest rate, and the interest rate is going to be 0.068 because it's 6.8%, moving the decimal twice, divided by, we're compounding quarterly, so that would be n equals 4. And then in the exponent, I have 4 times, and we're going out 18 years. Now, with that exponent, you could do one of two things. You could just go ahead and multiply 4 times 18 and use 4 times 18 is 72. You could use 72 in the exponent to throw this into your calculator, whether you're using a phone or any scientific calculator, and that's helpful. Or if you're using Desmos and you can actually see exactly where everything is, you could use parentheses around that exponent and type it in exactly like that in Desmos, in that scientific calculator form where you can actually see every little thing and see that it is calculating that exactly. So if you do that, either way, 80,000 divided by 1 plus 0.068 divided by 4 to the 72 power, we would get a starting value of $23,767.38. So this is one other thing you might need to do is think about how much you start with instead of how much you end up with. So this is when you need to find a starting value for a particular goal you have for the future.